Welcome back. Today we're going to talk about parallel lines and a line that we're going to call the transversal. So a transversal is a line that cuts across two other lines, and the lines happen to be in the same plane. Now this is a plane like a two-dimensional plane. So it cuts across these two lines and it creates two separate intersections, the top one and the bottom one here. Now when it does this, it ends up forming 8 angles. Okay, so the transversal is named with this letter T, and lines A and B form 8 angles. So 1, 2, 3, 4, 5, 6, 7, 8. There's 2 clusters of 4 angles each. So one in the top 4, and the bottom 4. Now, we are going to talk in specific about a transversal that cuts across 2 parallel lines. So our lines for us in 8th grade and in geometry, when you use that, there's a lot of special properties when A and B are parallel. So the way that we write that geometrically is we say that A is parallel to B. So this little symbol means parallel. Okay? Now, one piece of terminology that you need to know is interior and exterior. That's what we're going to use to classify the angles. Now, the way that we look at that is the interior is the space between the lines A and B, where the exterior is the space outside of A and outside of B. Okay, now in this situation, notice that the transversal here cuts across the other way. The first one that we saw one cutting from left to right. Here we're going to see one cutting from, well, it's from left to right, but it's from the top to the bottom, I guess. So it's very similar. The same thing happens when it cuts either way. In fact, you could actually just turn this around and it would be the same, the diagram as it was before. Okay, so again we have our interior, which is the space between the two lines, A and B, and we have our exterior, which is the space outside of both lines. Okay, so in this diagram, we are going to talk about pairs of angles. So not just single angles, but 2 angles taken together. So the first pair that we see is the angle is called corresponding angles. Now these angles lie on the same side of the transversal and on the same side of lines A and B. All right, this can be a little bit confusing. So let's focus on angle 1 and angle 5 right here. So if I actually draw angle 1 right here, okay, I can see that angle 5 is corresponding because all it does is it takes a, let me lock this down here. All it does is it takes angle 1 and it translates it down to get angle 5. So angle 1 is above line A and to the left of the transversal, and angle 5 is above line B and to the left of the transversal. So essentially, angle 5 is in the same position that angle 1 is in, except it's in the bottom cluster of points, right? So we have these bottom cluster of angles, rather. We have these 4 angles that are on the bottom and the 4 angles are on the top. Now 5 takes the same spot that 1 takes, but it's just in the bottom cluster, okay? Now angle 5, the corresponding angles are congruent. Okay. Alternate interior angles are non-adjacent angles. Non-adjacent means that they are not next to each other, that lay on opposite sides of the transversal between the lines A and B. Okay, so interior means between the lines. So we have this space interior. And they are non-adjacent angles that lie on opposite sides of the transversal. So alternate interior. So for instance, 3 and 6. So notice I'm going to highlight just quickly the interior angles here. So all 4 of these angles are interior. Okay, so the one that's adjacent to 3 is the one that's 4. But we want non-adjacent angles that lie on the opposite side of the transversal. So 3 and 6 are alternate interior because they are on different sides. 6 is on the right side of the transversal and 3 is on the left-hand side. And these angles right here are also going to be congruent. Okay. Another pair of alternate interior angles is angle 4 and angle 5 are alternate interior angles. All right, likewise, alternate exterior angles. So I'm going to highlight the exterior angles with green. These are exterior, 1, 2, 7, and 8. Now, alternate exterior are the ones that are on that are exterior, right? And they're on alternate sides of the transversal. So for us, our alternate exterior angles are going to be angle 1 and angle 8, and angle 2 and angle 7. Okay, and these are also congruent, meaning these angles are equal to each other. Now, you can see that because look at the way that angle 2 right here. So angle 2 looks a lot like angle 2 and angle 6 are corresponding angles, right? They are in the same position but in a different cluster. And angle 6 and angle 7 are vertical pairs. So it means that if I flip this one around, if I flip it up down, I'm going to get, I have to turn it a little bit, but I would get angle 7. Okay, because vertical angles like 6 and 7 are congruent. You learned that in 7th grade, and corresponding angles are congruent. So that means the alternate exterior angles are also congruent. You'll see that that's the same angle. Likewise with 5 and 8 are congruent because they're vertical angles. 5 and 1 are congruent because they're corresponding. So 1 and 8 must be also congruent. Okay, the last pair of angles that we're going to study is same side interior. They lay on the same side of the transversal T in their inside. Okay, so same side interior would be like angle 3 and 5 and angle 4 and 6. So 3 and 5 and 4 and 6. Now, what we know about this is if we look at 7 and 3, for instance, we know that 7 and 3 are congruent because they are corresponding angles. They both lay below their respective lines and to the left of the transversal. Okay, so I know that 3 and 7 are congruent. I also know that 5 and 7 make a linear pair. So angle 5 and angle 7 together, if I add them up, they lie along a straight line, and all together they represent 180 degrees. Okay, that's angle 5, sorry. So I know that they can't be identical. Also, notice that angle 5 is an acute angle. It's less than 90 degrees. And angle 7 is an obtuse angle. It's greater than 90 degrees. So I also know that they're not going to be congruent. Okay, but I do know that they are supplementary, meaning together they add to 180 degrees. So looking at same side interior, I know that 3 and 7 are equal, and I know that 5 and 7 are supplementary. So now what I also know is that angle 3 and angle 5 together are supplementary, meaning that they add up to 180 degrees. So they add to 180 degrees, and this property is called their supplementary angles. Okay, so most angle pairs that we studied are congruent, but these happen to be supplementary. Okay, we can use that in order to, that's just an extra picture there. We can use that in order to find a missing angle when we've been given an angle. So for instance, if I'm actually been given one angle in this situation, I can find all of the angles, which is really nice. By the way, this little notation here, the fact that these two had the same number of little arrows, notice this is not the arrowheads to indicate that these are lines and not line segments. These are another notation here. It means that these, taken together, it means that these lines are parallel. Okay, so if I've been given that angle 7 is 125 degrees, then I can actually find all the other 7 angles in this cluster of 8. Well, actually, let me first find in the cluster of 4 here. So here I know that 125, that angle 7 and 6 are congruent because they are vertical pairs. Recall that from 7th grade, right? Vertical pairs are two angles that lie across from each other when two lines intersect. So These are vertical pairs incongruent, and the red are vertical pairs incongruent. The red and the purple are not congruent to each other, but they are supplementary, meaning that the red and the purple add up together to get 180 degrees. Okay, so I know that those are 125. I also know that 5 and 7 add up because they're along a straight line. They add up together to get 180. So I can subtract this together to get 55 degrees. Okay, so I know that angle 5 is 55 degrees. And then I also know that 5 and 8 are vertical pairs, or vertical angles, so I can mark this as 55 degrees. Okay, so I'm trying to get angle 2. Now, I actually didn't have to do all those things, but as you know, I wanted to show you if you did need to get any of the angles in the bottom cluster, then you know them just by the relationships that you learned in 7th grade and 6th grade. Now, if I want to get angle 2, if we look at angle 7 and angle 2, they're both exterior, right? So if you need to, what I like to do sometimes it's difficult for me to see geometric relationships, so I like to use a highlighter in order to show certain things. So by any means, use a highlighter if that's the case for you. Okay, these are the ones I've highlighted are exterior. Now notice that 2 and 7, 2 is on the right side of the transversal and 7 is on the left side. So these are alternate exterior angles, and so I know that they're actually congruent. So I know that angle 2 has to be 125 as well. Okay, now if I had to get at any other angle in the top cluster, I know that 2 and 3 are vertical angles, so this is also 125. I know that 1 and 5 are corresponding, so this should be 55. And I know that 1 and 4 are vertical, so this should also be 55. When you have two parallel lines cut by a transversal, there's only two angle measurements here. Every angle has either one of the two angle measurements. Okay, now this one requires you to set up an equation because there's an unknown in this equation, in this situation, as opposed to this one where I just gave you an angle measurement. Okay, but it's not really a big deal because I know that these two are same side interior. And I told you before that same side interior add up to 180 degrees. So if you're ever given a situation where you need to use an equation, you need to set up an equation, there's only two situations. Either the angle measurement, let's say angle, I'll just have this indicate an angle. Either the angles add up together to get 180 degrees, or the angles are congruent to each other. So you either set up a situation where you add the two expressions to get 180, or you set up an equation where the two expressions are equal to each other. All right, and this is when the angles are not given to you in degree measurements, they're given to you as expressions. So for our situation, these are same side interior, so they're going to add together to get 180. So it's very easy for me to solve this equation. This is 180 degrees. Divide by 9, I get x is 20. Now I haven't answered the question yet because I want to answer what is the measurement of this angle. I only have found what x is. So angle V WZ is this angle right here. V, start with the outside. WZ is this angle measurement right here. Okay, and that's angle 3x. So since x is 20, I know that 3x must be 3 times 20 or 60 degrees. So this angle measurement is 60 degrees. Okay, now let's say that instead of giving you 3x and 6x, I gave you 3x here and let's say I gave you alternate side interior. So I gave you that this was, let's see, 5x plus 10. Okay, well, these two are expressions, so what I would have to do is set them equal to each other. 6x is equal to 5x plus 10. Like that, and then you could solve it that way. And then you would still find out what x is, and then that's an intermediary step because you need to put x back into the expression to get the actual angle value. Okay, and that's it. That's the end of the lesson for today.